So I'm going to come up here and introduce you, and then you can take over. Well, welcome everybody to our second First Wednesday lecture, and this is a kind of a treat for me. It's the first time since I've been here that I've faced a live audience. You guys may seem like it's a small audience, but it's a big deal in sort of the transition. And we're going to a hybrid model with both a live audience and a live stream virtual audience. I think that might be the model for the new normal going forward. And I think it's a good model. We can reach more people. So tonight we have Cassandra Davis, who's the head of our volunteer programs now, and has been really integral in developing the community science programs. And then she's going to be talking about the green sea turtle, which is a charismatic animal, a spectacular animal, amazing natural history. Used to be much more abundant. At one time, there would be 10,000 of them harvested each year for food, and obviously depleted. And I really like that the aquarium and a few other places have gotten away from calling things citizen science and calling it community science, because that's really what it is. It's not just scientifically valuable, but it builds a community of people who are engaged in conservation and science. And Cassandra, thank you very much for agreeing to do this with us.
Well, welcome everybody. I am going to tell you a little bit about sea turtles and a lot about community. As Peter was mentioning, this is a project that helps us to learn more about natural history, but it also helps us to learn more about our community. And in this specific case, with the urban sea turtles here in Long Beach area, at the border of Long Beach and Seal Beach, we really have a chance to learn more about the world that we're building and what is affected by what we do and the actions that we take. So you will see some pictures like this one where we have a turtle surfacing right in front of one of our power plants. And these are our local charismatic megafauna, local sea turtles in Southern California. These are also unique because they are the northernmost known population of green sea turtles. They are found right here at the other side of Long Beach. We have two rivers that are coming out in Long Beach. We have the Los Angeles River and the San Gabriel River. And in the San Gabriel River, in the mouth of that river, we have this population of green sea turtles that we're starting to learn a little bit more about. And we're starting to learn a little bit more about that because of some amazing and incredible community science volunteers. So our green sea turtle is a pretty interesting animal. The sea turtles have been around since the time of the dinosaurs. They started off on land and went back into the ocean. And that means that they breathe air. They come up for air, which is very fortunate for us because it makes it a little easier for us to spot them. It also means that they're cold-blooded. They do need a certain temperature in order to survive. For the green turtles, that's about 50, 55 degrees for them to be able to thrive. And here in Southern California, we're right on the border of that habitable landscape. We also have a very large size for our sea turtles. They're actually the largest of the hard-shelled sea turtles. We do have one sea turtle that's larger, and that is the leatherback sea turtle, but they don't have a hard shell. So even though we find them off of our coast here in Long Beach, with the green sea turtles, we're going to focus on them. And these green turtles are also doing something really interesting. They are returning back to their nesting beach. That's a fact that a lot of people kind of have an idea about. And I will start off, I will tease you a little bit by saying that our green sea turtles are not nesting here in Southern California. And we have discovered a little bit more about where they nest. But first, let's take a look at some extraordinary facts for the green sea turtle. The green sea turtle is not always green on the outside, but it is green on the inside. That's where it really gets its name. And in fact, many of the turtles that we see that are part of this green sea turtle family are a darker color, a dark brown or even a black color, and are sometimes commonly called the black sea turtle. The ones that we tend to see are in what we would call the juvenile phase. So they're between 5 and 25 or 50 years old, usually before they reach the full reproductive age, so before they're that full size. And we are seeing them in their life phase where they are feeding on more than just algae. Although they do feed on algae, they feed on sea lettuce, they love seagrass. They also tend to feed on invertebrates, tunicates, other animals that are easy to pry off of rocks or grab with their beaks. They also have the ability to hold their breath. So the green sea turtles will generally surface about once every 20 minutes if they're at normal activity levels. If they're resting, they can stay underwater for extended periods of time, for hours at a time. And if they're very active, they're going to surface, they're going to come up for air multiple times, and that's when we get to measure a little bit about what they're doing and make some guesses, some assumptions on what's happening. So here's some fantastic footage of a green turtle munching away at seagrass. And what's interesting about the green turtles eating seagrass is that they are important to the seagrass habitat. And their presence eating the seagrass actually helps the seagrass to grow, a little bit like mowing a lawn. So they're stirring up a little bit of sediment. They're not necessarily taking out the roots. And a green sea turtle is essential for good seagrass beds. And that's where we get to our population here in Southern California. When did the green sea turtles arrive? We can't say for certain. We can start to say that there was a known presence of sea turtles here in Southern California, but it was thought that they were transient, that they would come up during perhaps warmer waters and leave again. And when they would come up every once in a while, maybe there would be an encounter that made them stand out, and they might get care at our Molina Animal Care Center. But in 2008, we had a volunteer here at the aquarium, Hugh, and his wife Pam. They went out to the San Gabriel River following some leads from local fishers, and they studied the turtles. Month after month, they came back and they found evidence of sea turtles, and they were able to get some incredible photographs of the sea turtles in the river during that time. These community science volunteers were able to document year-round presence of the sea turtles in the river, and that allowed us to expand a little bit of our knowledge and to expand the range of the sea turtles just a little bit more. Prior to that, we knew that there were sea turtles found in the San Diego area, but we did not have documented proof of year-round residence here in Southern California. With the help of Hugh and Pam and a few other volunteers, we've been able to begin to learn a little bit more about the sea turtles. One of the things that we have been able to learn, and the NOAA National Marine Fisheries Service programs have been able to capture, tag, and even produce some genetic samples from some of the turtles who are captured, and trace their lineage. And so we know that this group of sea turtles that we find up here in Southern California, in Long Beach, is genetically tied to sea turtles nesting in Michoacan. So these turtles are swimming about 1,500 miles, and they are laying eggs on nesting beaches that have been protected by the Mexican government and protected in many cases by volunteers as well. These nesting beaches and related islands just off the coast are an essential habitat for these green sea turtles. The protections have led to a growing population. Now, PK mentioned as he was introducing me that there used to be these incredible harvests of green sea turtles, and it is true. The green sea turtle and many other sea turtle species are harvested for their meat, to make turtle soup, and sometimes harvested for their eggs. But they are now a protected species, in part because of what we have been able to learn about the population. And that protection has led to about 1,400 nesting, annual nests in Michoacan alone, and that number is growing. It's led to a success story. What we're seeing with the green sea turtles, in particular the green sea turtles here in the eastern Pacific, their populations are starting to recover. Their populations are starting to grow. But it is a slow process because it takes about 25 to 50 years for a green sea turtle to reach sexual maturity, to reach the we are seeing turtles of a size that just based upon their size, we can estimate a little bit about their age. They are between 5 and 25 years old. Too young, exactly. So we do not have nesting beaches here in Southern California, but we have an important habitat. And with the East Pacific Green Sea Turtle Recovery Plan that the National Marine Fisheries Service, NOAA, has developed along with other nations as we try to navigate this global ocean. Some of the priorities include minimizing things like boat collisions, which can be harmful for turtles, so enforcing speed limits in areas where turtles are known to habitat, minimizing incidental bycatch, entanglement with fishing line, or ingestion of fishing hooks, which can be dangerous for the turtles. One simple thing that can be done to minimize that and minimize harm in fishing is, if you're a recreational fisher, use a circle hook instead of the traditional J hook. You can catch just as many fish, but it's easier to get the hook out. And in fact, if a hook is left in a species, they are able to usually process it out more easily. It also includes identifying where these turtles are, what they're doing, and how many there might be. And that's where this community science program really comes in. I can't take you personally to the river right now, although I hope that perhaps you will sign up for a community science event and join us in the Sea Turtle Monitoring Program. But this is a view of the river. Up there at the top, you see where the San Gabriel River transforms from the channelized cement troughs that you might know into a more open landscape. And this is what we're talking about when we're talking about the sea turtles being in the river. Although there have been incidents where sea turtles during high tide have made it over this rocky berm, and they have traveled up that cement channel. But for the most part, the main population is down there in that main waterway, which is brackish water. It's a mix of salt water and fresh water. The fresh water is coming down those channels, and the salt water is coming from the ocean, which is just a little bit further down this way. So this is a close-up where we are at that berm. You can see the fresh water coming down. Yes, there is water in Southern California. There we see the sea turtles. There are actually two of them right there in that moment. And then yes, a shopping cart and a few other things. And then we turn down to the main channel. That shopping cart and that debris that you see is fairly common to see along our river. It's fairly common to see debris along our beaches as well. And that's because in Los Angeles and Long Beach and really in Southern California, you have a complex network of streams and tributaries and rivers, and you walk by them every day. Every street corner, every storm drain is coming right down into the rivers and flowing into the ocean. So we see debris, but we see less than we used to. One thing we see less of is we see fewer plastic bags. And that's in part because of things like plastic bag bans. So zooming back out, when we look at the river, we have groups of volunteers who are coming to these red dots, these stations, and they are observing the sea turtles from these locations. Over the past couple of years, since 2012, we have trained over 340 community scientists. They're recording this behavior. They're not there all at once. I don't want you to get concerned with COVID. We have lots of physical distancing, and that is over the time of this 9-year period. So in that time, we've also had many community scientists who have gone on to form careers elsewhere and to build their documentation and information so that they can grow and be able to provide more input for science. In this map, we also have just the tiniest peak down here at the beach. And we can see the inflow for Alamitos Bay as well as the inflow for this brackish water area. And right here, we have a very important and crucial area for the sea turtles. Even though we don't have any sea turtles specifically in that area, that's the Los Cerritos wetlands habitat. Some of you might be familiar with wetlands. You might be familiar with the wetlands like Bolsa Chica. The Los Cerritos wetlands is not at that level yet. It is a heavily impacted area. But it is one of the last remaining wetlands areas here in Long Beach. When we come to wetlands, wetlands have been developed over, they have been filled in, and we have engineered land out of those wetland habitats. What is interesting about that is we have the ability to reverse it. We have the ability to engineer wetlands back and restore those habitats. And I want to share with you a little bit of data. I know that the pictures are more interesting, but this data tells a story, and it's going to connect us from the sea turtles to the wetlands. So this is all of our data. This is the surfacings recorded by our volunteers over time. I have 2 blue bars here to identify some anomalies in the data. One anomaly is over here at the very beginning. We had our pilot sessions, and then we had a funding gap right here at the very beginning of about 3 months where we needed to determine how to continue the program. We have a couple of rainy season events, one here and one here, where the sea turtle monitoring was called off during a very rainy day. And then we have COVID-19 over here. Those are the only interruptions in 9 years in this data. That is an incredible accomplishment. And that is only possible because of community science. There is no single researcher, no matter how dedicated, no matter how interested, who can gather 9 months of continuous monthly data. And particularly monthly data that involves a 2-mile stretch and that involves observing animals. Because these are not animals that are here at the aquarium, easy to spot, and some of the animals at the aquarium are not always easy to spot. They have their preferred hiding places. But these animals, they will swim where they like to swim and go where they like to go. And in a way, you can see that reflected in this data as well. In addition to those lower points, you might also notice these high peaks. These high peaks mark summers, typically falling between June and August. The high peaks are the highest levels of activity, the highest levels of surfacing for these sea turtles. So remember, they're coming up for air. If there are more turtles in this region, and if there is more activity, if they are swimming around more and if they are more active, then we will see higher numbers, we will see higher peaks. If there are fewer turtles in the observation area, or those turtles are more sluggish, which as reptiles they tend to be in colder waters and colder seasons, then we will see lower peaks. And we can zoom in on this data and learn a little bit more. So this is 1 year's worth of data. I will caution you, it is 2019. It is not 2020 for hopefully self-explanatory reasons. This is 1 year's worth of data for the individual stations. Remember that map with all of those red dots, those red locations. By zooming in on this data, we learned something very interesting. We thought that the highest number of sightings and surfacings would be around the outflows for the power plants. Remember that power plant from the first slide? Those power plants use something called once-through cooling in order to help to create power for the cities of Los Angeles and Long Beach, Seal Beach. They are pulling in seawater, using it to cool the power plant and pushing out warm water. Now that is regulated, and the water is usually around 90 degrees or so as it's pushed out, or colder. And that creates kind of a jacuzzi for these sea turtles. So we thought that the most activity would be at those outflows where we have the power plants. Instead, the greatest number of surfacings by far is this gray line up at the top. That gray line is station 3. That is the outflow for the wetlands. Now the water there is also a bit warmer. The water there is also full of food. So are there more sea turtles at that outflow? We can't say for certain. We're working on that. But there's absolutely more activity at that outflow. And that is an interesting thing to investigate. That tells us that spending efforts in restoring those wetlands habitats will be beneficial for the sea turtles. It also tells us that these sea turtles, who have a 25-year life phase where they come up to Southern California and then head back down to nesting beaches in Mexico. These sea turtles that live on a slower timeline than many of us, it is possible that they've been around and been in this area long before those power plants were on the river. That's one of the key questions that this study hopes to investigate and discover more about. One of the reasons that we developed this long-term study is so that when once-through cooling is phased out, which is planned, and which happened at power plants down in San Diego that also had sea turtles surfacing, once that is phased out, we will still continue to go along the river and observe the sea turtles and see how these patterns change. So that is a long-term goal in this study. But perhaps our long-term goal should be a little bit different. And perhaps our long-term goal should be looking at this engineered area and looking at all of the individuals that we can bring together as part of our community science or part of our conservation efforts, and see if there's a way that we can engineer this area better. See if there's a way that we can continue to grow and expand these wetlands by learning more about them. So our community science program, as Peter mentioned, is essential because it creates a community of learning. It creates a tremendous group of people who are invested in these incredible animals that have been swimming around our waters for hundreds, thousands, millions of years. And it allows us to learn more about our local community. The wonderful thing about Long Beach and Los Angeles is that we have this incredible urban wildlife that is just around the corner. Whether we're talking about the green sea turtles or talking about juvenile white sharks or talking about red-tailed hawks and osprey, or perhaps rabbits and deer and raccoons and possums, we have all kinds of different animals that we can learn about. And we are starting to have technology available that allows us to learn more. So I mentioned that we're trying to learn a little bit more about the age of these sea turtles, how long they've been here, where they go. And one of the ways to do that is to tag them, capture them, tag them, release them. The tags are usually a pit tag, a small metal tag that's on one of their flippers. But there's new technology that allows us to go beyond pit tags and identify individuals. Photo identification has been used for many, many years, and the aquarium has participated greatly in photo identification of whales. Scientists have been able to show that these facial scutes, these plates on the face of the sea turtle, are like an individual fingerprint. Now, it can be difficult, based upon photos, for a human to quickly identify this might be the same green sea turtle, this might be a different one. I can assure you that when you've stared at 300 pictures of green sea turtle faces, they really do all look the same. Every once in a while, there's one that stands out, but 90% of them look the same. But we have computer algorithms that can begin to identify these contrasting patterns. These three pictures are the same sea turtle. And the computer algorithm can connect those dots, and we have volunteers who can confirm that these are the same sea turtle. So we do a computer comparison and a manual comparison. We're using a program called HotSpotter, and we are also contributing to something called the Internet of Turtles. But we gather these photos from a number of different sources. These photos are taken by photo ID volunteers who go out with their cameras and take pictures. And they are also submitted through iNaturalist, which is an online community science program. If you've never explored it, I encourage you to do so, especially if you've ever encountered anything that you weren't able to identify that's an organism, whether it's a fungus or an insect or a plant. You can put it on iNaturalist, and dedicated community science volunteers, staff at learning institutions like the Aquarium of the Pacific and the Natural History Museum, they will go in and identify what you have put up there. So it's a pretty fantastic program. They will tell you if you saw a green sea turtle or not. Maybe it was a different type of sea turtle. They will tell you whether or not that insect really is a flying termite, or whether you should be worried about that particular snake that slithered by. So these technologies, combined with having these phones in our pockets that can be computers, that can be cameras, that can record video. These allow us to start to see more into our natural world and learn more about our natural world. One of the goals with the Photo ID program is to continue to network with other sea turtle monitoring programs around the world. We don't expect that we will ever find a green sea turtle that went from here to Africa, but we might. In fact, everything that we know about the distances that sea turtles travel came about through a very low-tech version of the photo ID. It came about through those pit tags that I mentioned, and scientists tagging the sea turtles and asking for those pit tags back. And fishers around the world began to send those pit tags back, and they discovered that sea turtles travel long distances. They travel thousands of miles. They discovered that sea turtles live for long times, whereas before it was thought maybe 1 or 2 years. And they discovered that sea turtles can help to connect us all. So beyond community science, the Aquarium and National Marine Fisheries Service and individuals at the Los Cerritos Wetlands, as well as the City of Long Beach and City of Seal Beach, are all connected and dedicated to conservation. Conservation comes in a lot of different forms. It comes in the form of signs, just alerting people that these sea turtles are present and giving a hotline to call if one is entangled. They come in the form of habitat restoration. You can see 2 of our sea turtle monitoring volunteers working on the wetlands post-identification, post-spotting of sea turtles. And it comes in the form of education, of talking to others and sharing what you know, and learning more, getting involved and seeing what you can discover in order to begin to transform this area, which has already been heavily transformed. We have these levees that prevent our cities from flooding, but they are almost 100 years old. The technology that put our channelized rivers in place came about in the 1930s and 40s. We now have technology that allows us to restore the soft bottom of these rivers, to restore those natural habitats. And we have the ability to go through and engineer something different. So we could create a habitat that allows these green sea turtles to thrive and to continue to be part of our story in Long Beach, Los Angeles, and beyond. With that, I will begin to open this up for questions. I know that we have some live audience members as well as some viewers who are on our virtual streaming. So if you are watching from home and watching virtually, you can use the Q&A function on your Zoom meeting to ask questions.
First of all, thank you for your talk.
Yeah.
Well, thank you.
So I want to start taking questions, but I have to make, I spent 30 years of my life being a conservation biologist, and what I like so much about the story Cassandra has told is too often conservation is about the demise of the planet. And it doesn't need to be that way. It can be about recovery and regeneration, and that's very, very cool. And that is the other, but there are 2 things that really struck me before I turn it over is you mentioned this notion of the community scientists confirming something from a high-tech source of information. I think that's the future of environmental science. It's not just, this is going to happen all over the world, not just species by species, but also it'll be community scientists who confirm satellite images with respect to crimes against nature. You know, plastic leakage, things where people are violating regulations. And that's something that I was really excited that I didn't plant that you used that. I think that notion of the community confirming what technology tells us, because we can never just rely on the technology. There could be too many false positives. That's very cool. And the one other thing I would say before I turn it to questions is, because I was a math nerd as a conservation biologist, you might think that these turtles, you know, when Cassandra tells you about their life's history, and you got all the eggs and the nesting down in Mexico, but you have this urban population that you might not think is so important if you were just to think like, what's an urban population going to do? There's a concept in conservation called reproductive value. And the intuition is this: supposing you're down to the last few individuals of the human race and they're going to be on one island, what age are you going to put on that island to recover the species? It's going to be the equivalent of the age that she's talking about. So one of those green turtles at that age is incredibly valuable to the whole species. And it's a math geek concept, but it's really an important notion that value of each one of those turtles is huge from a population perspective. That's all. I'm sorry to interrupt, but I got so excited because this was my career for a while. Questions?
Oh, that is a great question. Do we know the male-female ratio that we're spotting out here? No, not at all. It is difficult to tell the sex of a sea turtle before it is of reproductive age, and very difficult to tell from a surfacing in the water. So there are a couple of things we can extrapolate from the captures that have been done by NOAA Fisheries, and they've been able to capture, measure, and release many of the turtles. But because so many of them are juvenile and have not yet developed that differentiation, which, for those of you who are wondering, if it is a male, it's going to have a much larger and thicker tail. Its basically belly is going to be indented a bit. And it's going to look a little bit different than your maybe typical drawing of a sea turtle. And the typical drawing of a sea turtle is probably going to be a female sea turtle. The females do tend to be a little bit bigger, but again, that depends so much on age, availability of nutrients, and temperature of water, growth rate. All of those things factor into the size of the sea turtle. The females do tend to be a bit bigger.
Go ahead. Yes.
I've lived here all of my life, and I don't recall seeing the sea turtles when I was a youngster here. I'm wondering if a lot of the sightings now are based upon the sea level temperature rise, which is driving the turtles from the warm waters of Mexico to perhaps some little cooler waters here. Is that an idea?
So that's an interesting idea. Perhaps the warmer waters that we are seeing due to climate change are providing kind of a conduit for increased numbers of sea turtles in this area. And there are a lot of possibilities, but from the stories and oral histories that we have heard, there is absolutely evidence that turtles have been present in these areas for decades, if not for centuries. And we are seeing what seems to be an increase, and I'll just go back to this data if I can get there fast enough. What seems to be an increase in sightings, you'll notice from 2014 through 2016, we did have a warm water blob, a warm water incident, and we have seen some increased numbers in our data. However, we have also gotten better at spotting. So there is a little bit of a question mark on this data although it follows similar patterns as to whether or not we've gotten better at spotting, whether or not the habitat has improved as the wetlands have been restored, and whether or not there's some other influencing factor in those turtles arriving. And I will also add that climate change in general and the warming of the waters is causing us to see a number of species here in Los Angeles, Long Beach areas that we would not normally see. Just here at the aquarium, we have some tropical species that have come up during warm water incidents and been stranded in this area. And there are reports of seahorses in local waters. We have upstairs a porcupine fish that has grown very large, but was stranded in a warm water incident as well. So these are reflections of a changing ecosystem and changing habitats.
Well, that area of the lower San Gabriel has always been known as Ray Bay. I mean, you know, when we surfed over there, we'd paddle over and catch the warm water and unfreeze, because we didn't have any surf on this side of the jetty.
Yeah.
Head on the southeast side. So, I mean, that's always, you know, for prior to my lifetime, back when the Indians were here, that's always been a warm estuary. And whether they discovered it recently or not, it's always been of that nature.
So that area has always been a warm estuary and has been known for a very long time as Stingray Bay or Ray Bay. And it absolutely has it has a number of juvenile species. We've seen juvenile sharks, we've seen juvenile rays, we've seen dolphins swim up the San Gabriel River, sea lions and juvenile sea lion pups as well. And it is a thriving area. Nearby, we have a number of other wetlands that this would historically have been a wetland, a full marshy seagrass pool-filled area. And it is very possible that the sea turtles would have been thriving in that environment as well. And we see evidence of that. We see sea turtles in the nearby wetlands as well.
I want to make sure we answer some of the questions from the virtual audience, especially these. So how do you get to be a volunteer at Station 3?
You bring coffee. No, we used to gather around coffee and donuts, and one day we will again. For Station 3, actually all of our stations are independently assigned, and even though I focused on Station 3, it is not the only station that sees sea turtles or that sees high levels of activity for sea turtles. One of the interesting things we have seen is there has not yet been a month that we went out and saw nothing. So any data nerd will tell you 0 is still a number. 0 is an important data point. We need to know when you see nothing. There has not yet been a month where we went out and saw 0 sea turtles across all of the stations.
Another sort of related question, but I want to make sure we get these in for the audiences. Are there dive community science opportunities?
Absolutely. There are some incredible community science opportunities for divers, and one I would encourage you to investigate that the aquarium is involved in is called spotting giant sea bass. So if you are a diver, if you see a giant sea bass of any age and you have a picture of it, just like we can use the facial scutes of the sea turtle, we can use the spots on a giant sea bass from a very young age in order to identify those individuals. So that's one example of many. There are reef check and other opportunities that are available for community science, but divers absolutely have opportunities.
So how about some questions from our elite live audience? Yeah, go ahead.
Yeah, do you suspect that the population in San Diego is the same population as here in Long Beach? Do they also come from Michoacan, Mexico, or some other beaches?
Hi.
How often, and they go back every year? All of them migrate back every year, is that correct?
So, two parts to the question. I'm repeating it for the audience that is watching virtually and anybody who wasn't able to hear. But the population in San Diego, is that tied or connected to this population? Absolutely. We absolutely see evidence that these are similar and related populations. And in fact, in San Diego, they do tend to have sea turtles that are larger and older. Ones that have been tracked with satellite tags as returning down to Michoacan and some of the islands offshore, and returning back to San Diego. So we do absolutely see those ties both genetically as well as with tracking. And with those populations, in many cases, it's a 2-year cycle. There are some cycles for the sea turtles that'll be every 2 years once they are of reproductive age. So the ones that we are seeing in the river, many of them are too small to join that nesting population, crawl up onto the beach. So they're here all the time. They're at the furthest edge of their habitable range. They are young, and they are essentially the teenagers who have kind of been kicked out of the house and don't have any other place that they're going to be having prime feeding ground. So this is the edge of the population, but it's a very important part of the population.
Boy, wouldn't I like to be 50 years old and called it adolescent. But, other questions from the audience?
I have yet another. Are there plans with the Los Cerritos wetlands restoration to try to accommodate the sea turtles, such as putting in beach areas or something that's environmentally friendly for them?
How can the Los Cerritos wetlands contribute to a better habitat for these sea turtles, and what could potentially be put in? One of the best things that, if it would be possible, would be to allow water inflow into the Los Cerritos wetlands beyond the one outflow area. So that one area at Station 3 is not large enough for a sea turtle to pass through. So the sea turtles are not getting up into that key seagrass area. And there are opportunities for the tidal influence in that area to be increased if that water opportunity was to be increased. That involves some significant re-engineering of the area, because that would involve changes to the levees and changes to the bike path and the infrastructure that's been developed. Right now, one of the best things that can be done in the Los Cerritos wetlands for those sea turtles is to continue to restore, continue to develop the wetlands area and the wetlands habitat so that it continues to provide that rich outflow for the sea turtles and a rich opportunity for their feeding and whatever else is having them be so active in that area. You know, we can't necessarily assume that it's feeding. Maybe it's just the most exciting place for them to play. But there's definitely a lot of activity at that one location.
Cassandra, correct me if I'm wrong. I'm not a sea turtle biologist, but their life cycle's reminiscent of a really slowed down salmon life cycle. In other words, where you're seeing them breed, where you're seeing them lay eggs is different than where they go to feed and grow to adults. And so it's two separate habitats. So you wouldn't necessarily think of beaches for sea turtles up here. Their business that they're going about is growth and feeding.
Yeah.
And the reproduction is back at the beaches.
Yes. And the green sea turtle in particular is tied to their original nesting beach, much more than the other sea turtles. There are a number of other sea turtles that will go to the area where they hatched, but not necessarily to the nesting beach. And the green sea turtles have a significantly higher nesting fidelity than other turtles.
I have a question here, another question from our virtual audience is, what do we know about the diet of these local, you showed some pictures of them feeding, but in general, what can you say about the diet up here?
Up here, these are, again, those adolescents. They will eat anything. They are omnivores, and they are feeding primarily on sea lettuce, seagrass, but also invertebrates, tunicates, and if they happen to eat a fish or two along the way, then they will. But primarily, whatever they can scavenge. They like to scavenge and scrape down by the rocks.
So that they're feeding with them on the bottom?
Yes. Yeah, they're feeding down below and then coming up for air.
Have there been any sightings in Alameda's Bay? Because there've been a lot of seagrass restoration in the marine area, and now continuing up, soon to be opened up into Colorado Lagoon.
Yes.
When they get that causeway.
So sightings in Alameda's Bay, absolutely. I have seen sightings in Alameda's Bay myself and in those surrounding areas. So based upon our data from the community scientists, the data that NOAA has been able to gather just on how many times they recapture a sea turtle for tagging, and the knowledge that these sea turtles are staying in place, they are not leaving, based upon some tagging and acoustic tag studies. We can estimate there are probably around 100 sea turtles in this area, not necessarily in the river itself, but in the surrounding bays, wetlands, and area of the San Gabriel River at any given time. Are they all green? As far as we have seen. Now, at the aquarium, we take in and rescue and rehabilitate turtles that become entangled or have a boat strike, and we have had other turtles. We have had a few other types of turtles on Olive Ridley not that long ago, but primarily green turtles here at the aquarium. And our sightings along the river have all been green as far as we can confirm. There was one potential hawksbill, maybe. But unless we have photographic evidence, we can't say for sure. And there was one very lightly colored green, which at that size may have the potential to be an Olive Ridley. So there's potential for there to be other species, but it is much more likely that those species would be transient, they would be passing through, and we've not had any second sightings of any of those.
Is that the way it is with sea turtles, like the greens are here, the Olive Ridleys are there?
Oh, is that the way it is with the sea turtle species? Like we've got one species here and one species here, and no, not necessarily. It depends upon the species, of course, but there are absolutely nesting beaches that are shared by different species. But they do tend to have their own specializations. So the green turtles, they are feeding primarily on the seagrasses and the algae. And then you have hawksbill that are feeding on corals and leatherbacks that are feeding on jellies. So each of the species has their own food that they're going after, and that affects where they are.
Go ahead.
Do you anticipate the population to remain the same after the power plants are gone? I think you mentioned San Diego didn't change that much or at all when the power plants were shut down. Do you anticipate a major change, or I guess my question really is, how much of an influence is that warm water? Traditionally, as the gentleman was saying before, the wetlands being shallow, of course, the water is warm. It's warmed by the sun. In a delta and estuary situation, of course, it would be traditionally warm, but not necessarily now, except for the influence of the power plant. Just how much do you expect the population to change or remain the same?
So for those who are watching at home, how much do we expect the population to change when that once through cooling is phased out, if that once through cooling is phased out, or how much do we expect it to remain the same? We don't know. And that's part of the interesting question in this study is what's going to happen if and when that once through cooling changes. One interesting point is we've had a couple of times where we've gone down with one of those kind of heat sensing photography, heat sensing radar. We've tried a couple of things just to see what can we discover, what can we find out. Sometimes the warmest part of the river is not near the power plants and it is not near the wetlands. It is up near where the cement meets the ocean. It is up at that rocky barrier between the freshwater and the brackish water. And that is also where in the wintertime we tend to see the most sea turtles. So there are other sources in addition to the wetlands of that warmer water. So that's one factor. And then the other factor is what are the other influences for the sea turtles to be in this area. In San Diego, when the once through cooling was shut down, yes, the turtles are still there, but no, they are not concentrated in those spots that they had been. So they are much harder to see and much more difficult to spot. Part of that is also the terrain. We've had a couple of pilot studies on water observation study that we hope to revive down in Carlsbad. And we've been able to spot in those hour-and-a-half long expeditions 1 or 2 surfacings of sea turtles. So realize that when I say we had 500 sightings in a single session, not at one station, but at a variety of stations, that is incredible. It is incredible to be able to see that number of surfacings and to see that urban wildlife.
Okay, we need to wrap it up. I
Yes,
have one
of course.
last question, but I also want to announce that the next lecture, the first Wednesday in May, 5th, will be sharks, keeper of the reef. And, just to you, here's a question you can answer. Are there similar monitoring projects in Orange County and San Diego areas? But before you answer, I want to say that this I see as really, I've been a university scientist, and you work on 2 to 3 year grant periods. It's only with community science that you can even answer your question, because no university researchers are going to go and try to answer that question. It's too uncertain. They wouldn't get funding for it. They're not going to get a publication. That community science in conservation is hugely important and much underappreciated, especially when the world is changing in so many different ways. And I'm glad we have, you're charismatic, so it's very cool. So, yeah, good answer to the question about other Orange County or San Diego opportunities.
We are hoping to reinstate our Carlsbad observation work, and we do have one of our volunteers, Sabrina, has been working down in San Diego. She has a website where you can post sightings and report sightings. So we don't have anything that's as concentrated as the San Gabriel River at this point in time, but we hope to be able to revive some of those projects further south. And it is absolutely important for the management of those areas, the management of those habitats. And if you're down in Bolsa Chica, Orange County, there are some sea turtles in the Bolsa Chica wetlands, and their presence there has influenced decisions on the wetlands and the future of the wetlands. And it's very important that we have these sightings, that we have this information to report back to National Marine Fisheries, to report back to state developers, and determine what the best courses of action are to continue to design spaces that we can enjoy and the turtles can enjoy and the sharks can enjoy, because sharks played a part in that Bolsa Chica story as well. And I absolutely encourage you to come listen about the shark project, because that's a very exciting one as well.
Well, thanks a lot for a really special night.
Thank you. Thank you for being here.